Okay, so in this question we have to show that the 4 points A, B, C and D whose position vectors are given to us are coplanar, right? So let us first understand what concept we will be using to solve this particular question. So let us say these are our 4 points. Okay, let us call this point A, this point B, this point C and this point D, right? So if I have to show that these 4 points are coplanar, the best idea is to make vectors using these position vectors of A, B, C, D, right? So I am making the vectors AB, AC and AD. These are 3 different vectors. Now if these 3 vectors are coplanar, then it will automatically imply that the 4 points A, B, C and D are in fact coplanar, right? So let us call this a small AB vector as B vector, AC vector as C vector and AD vector as D vector, right? So now if I have to prove that B, C and D vectors are coplanar, then we just have to calculate the box product of B, C and D vectors, right? Box product, which is actually the scalar triple product, right? And if this value comes out to be equal to 0, then using the property of box product I can say that these 3 vectors are in fact coplanar, right? So we will be doing this process now. Let us try to find these small B vector, C vector and D vector. So B vector is what? B vector is our AB vector, C vector is AC vector and D vector is AD vector. Okay, now how to get AB vector? AB vector is nothing but the difference of position vector of B minus position vector of A, right? Position vector of B minus position vector of A. So these 2 quantities are already given. Position vector of B is minus j minus k and position vector of A is 4i plus 5j plus k, right? So if you subtract these 2 quantities, you will get your AB vector, which is equal to minus 4i cap minus 6j cap minus 2k cap. You can see the calculation. Similarly, I can very easily write my AC vector and AD vector. AC vector will be the subtraction of position vector of C and position vector of A, right? That value comes out to be equal to minus I plus 4j plus 3k. Okay, and similarly your AD vector on calculation gives you minus 8 I cap minus j cap plus 3k cap. Okay, so we have our vectors with us. Now the only thing we need to do is try to calculate the box of BCD. Now finding box of BCD is very easy. We just have to calculate the determinant, which is formed by using the coefficients of I, j and k of each vector. So basically my first row will be minus 4, minus 6, minus 2. Second row will be minus 1, 4, 3. Third row will be minus 8, minus 1 and 3, right? So I will get my determinant as minus 4, minus 6, minus 2, minus 1, 4, 3, minus 8, minus 1 and 3, right? So either you can apply some properties of determinant to solve this, or since all these are numbers, we will not take much time to solve and calculate. So let us just directly open this. Let us just open this along the row 1. Okay, so I will get what? I will get minus 4 into 4 into 3, 12 minus minus 3, which is actually plus 3. Then minus of minus 6 into minus 1 into minus 1 into 3, minus 3, and minus of 24, minus of minus 24, which is plus 24, right? Then minus 2 into minus minus 1 plus 1 and plus 32. Just simplify this value and you will get the value of box BCD. This on calculation actually comes out to be equal to 0, which proves that the small vectors B, C and D are coplanar. And if BCD are coplanar, this in fact proves that the points A, B, C and D are also coplanar, and this is the proof of the question.